While we're doing this, coming out to you guys is old homework. Grab yours, pass it on. If you have an old assignment, that you need to turn in to me, just come put it right here on top of this chair. I'm not collecting the review today. I'll collect it next time. But if you have an old assignment you want to put, go ahead. Yo!
Hey, Sturm, that's what I was doing on the board earlier.
Yes, it did. All right, so what's on the calculator part? We're doing it right now. Okay, this first question. Perfect. Thank you. This first question is going to be a word problem. Spatial.
Yeah, that's a space shuttle.
All right. So this could be a definite type of example that you would see on the test. Okay, this would be on the calculator portion of the test. So what I want you to do is we have the speed of an automobile in miles per hour, and we have the braking distance. Okay, so what I want you to do is I want you to go ahead and plug this into your stat plot on your calculator. Things that we're going to find, things we're going to answer on this question is we're going to find the equation. We are also going to find two other things. We would like to know what the braking distance. Some of you guys are being bad. Is when doing 40 miles per hour would be. And then if you have a braking distance okay, so we want to try and answer those questions. So we're going to have to use the calculator on it. Turn your stat plot on. Plug your data into your stat plot. Get your window to fit where it goes. You have to turn your stat plots on your calculator. Okay, y equals, make sure you don't have any equations in there. But your x component will be the speed, miles per hour, and your braking distance is in feet. So 0, 3, 7, 10, 14, 16 goes in for your speed. Braking distance, which is your y, is 0, 6, 18, 28, 41, and 49.
Sir, syrup, something wrong.
Perfect.
Okay. All right, thank you.
Could be. Could be. I don't know yet. All right. So I'm going to run through this. So first thing I'm going to do, on my calculator is I'm going to go under y equals, make sure I don't have anything in my y graphs. So clear all those out. Next thing, I'm going to turn my stat plot on, make sure it's on. You can see on that last screen that was on, put stat 1 on, use list 1, list 2. Make sure we hit stat, then edit. And if you have things already in there, just go up to the top, hit clear, then your down arrow.
Wait, so you have 2 plots on?
I just have stat plot 1 on. Okay, if I have stuff listed, you go up to the top, you hit clear, then down arrow. So I'm going to plug 0, 3, 7, 10, 14, and 16 in. And then in list 2, I'm going to plug 0, 6, 18, 28, 41, 49. Would it make sense if you were doing 0 miles per hour that your braking distance is 0 feet? Yeah, I hope you're not moving if you're doing 0 or you're not having a brake. So once we have that in, what's the next step so we can see, once we have our stat plot on, what's our next step to see our data plotted? What do we need to do? It's zoom what? Zoom and stat. So I think it's zoom number 9, at least on mine. Okay, so if you find zoom 9, it's going to give you this. In this case, it does look somewhat linear. I want it to be a quadratic, so I just wasn't good on it. So I'm going to hit stat. I then am going to hit calculate, and I want to hit the quadratic regression, which is number 5. Hit enter. And so it's going to give us this, and our r squared value is the important portion of this, right? So the closer r squared is to 1, the better. So we're at 0.992. So if you were to earn a 99.92% on a test, I don't think you're necessarily worried about the 0.08 you missed. Okay? So I want to plot this on my thing. So I'm going to hit y equals. Where is it stored? Bars. Statistic. EQ. That'll plot it. Once it's in there, a graph. Uh-oh. Clear. Why is it doing this? Who messed with my calculator?
That one teacher.
That could have been. So stat, calculate. So I get 0.05 plus.
Wait, how do you get that screen again?
So stat, calculate, quadratic regression. Yeah. Let's not save my whole equation. All right. Hey, someone tell me what your equation is. 0.05 x squared. What's next? Plus 2.26x. And then what? What's the c? That's okay.
The C is
Negative 0.4409.
Yeah.
Okay. Then I can hit graph. So here it comes. Okay, so this is my quadratic. Good thing to do once you have it plotted is to go ahead and hit zoom out. Hit enter. That way you're able to see a little bit more of the parabola. Okay, so find the equation. The equation we found, our equation in this case, rounded is 0.05 x squared plus 2.26 minus or plus negative, what is it, 0.046 or whatever it was? 0.4409. Okay, so what is the braking distance when I'm doing 40 miles an hour? So first thing I have to realize, does my window go out far enough for 40 this way? It might. So what am I going to do to get that 40 mile an hour? Shh. I can zoom out. Then what once I zoom out? How do I find the 40 mile per hour? Second count. And I'm looking for a value, right? The second trace, I'm looking for a value. And my value I'm looking for is 40. So if I plug that in, if my window's large enough, it'll tell us. If it's not, it's going to tell us it's an error. So realize I'm plugging in an X value out here someplace. So I'm going to hit Enter. So if I'm doing 40 miles per hour, my braking distance is going to be about 170 feet. Okay? Now, if the braking distance is 70 feet, then how fast am I going? What do I have to do in this case? There you go. So I'm going to plug 70 into Y2. And this is going to create a horizontal line. So I'm going to graph that as it comes across. Am I worried about the intersection right here? That's a negative, mile per hour, so I know that's not going to work. So I'm looking for this intersection right here. So I'm going to go zoom, calculate. I'm going to look for an intersection. Now the big key is make sure I'm close to that intersection because there's two intersections. Okay? So I hit enter, enter, enter. So if I'm doing 21 miles per hour, my braking distance is going to be 70 feet. And that's how I go about doing that problem. Okay? So you will definitely see this type of problem. It might not be braking distance, but you have to realize, if it asks for a speed or an X component, that second calculate value. If it asks for a Y component, you have to plug in the horizontal line there. Okay? And then find the intersection. So that's the two things. If we're looking for the R squared value is important for us to use in order to determine if we have the right graph. Okay? So that's the first part of this. Let's move on. If I had a problem like this, and I wanted you to solve for X, how should we go about doing this problem? Square it, okay. What's some other ways we can go about doing this problem? I could square, maybe complete square, sure. What's another way we can do this problem? Plug it in your calculator, what do you need? You're absolutely right. How would I plug this into my calculator?
Wouldn't you want to use the 10
I would keep the 10 on the same side. Okay? This is how I'd go about this problem. Realize this. I have this right here. So, under my Y1, I would plug this. Under my Y2, I would plug this. Now, you can do this algebraically, but I bet you it's going to be pretty ugly if you do it algebraically. So if you use the calculator, so you go back and use the calculator, a few things you should do. Let's turn our stat plot off. So I'll go up to the stat plot, hit enter. Clear out our other two things that were there. And then let's plot under Y1 the square root of x squared minus 8 plus the square root of x. So I'm going to go the square root of x squared minus 8. Move the arrow over. Plus. So now you realize that's not under the radical anymore. Plus the square root of x. And then under Y2, I'm going to plug 10 in. Now, my window's goofy right now. Because, what reason? It's the last problem we did. That's what the window's set at. So a wise thing to do on the calculator is go zoom and take it back to zoom standard, which is zoom 6. And zoom 6 is going to have a couple of graphs drawn. We have this graph right here drawn, and we have this one right here. How do I find that point right there? Second calc. Then what? Intersect. So first curve, enter. Second curve, enter. Uh-oh. Oh, hang on. I gotta zoom the window out a little bit. Sorry about that. Alright, I had to zoom my calculator out a little bit. It wasn't able to see the intersection. So if you zoom it out, then it comes there, and then we can look for the intersection. So second, calculate an intersection.
I do zoom out that much.
Just hit zoom out, enter. I think it's enter, enter maybe. First curve, second curve. It says what? Oh, my cursor's got it. There we go. First curve. Second curve. Yes, sir. How are you? All right, so once I plug my two curves in, 7.75 is my answer to this problem. Now, I want you to look at something. That's not horribly hard to do. The hard thing to do on this problem is this. The hard thing on this problem to do is this. If I went and solved this, if I went and solved that problem, let's go back, split it. If I were to try and solve this, the way I'd go about doing this problem algebraically would be like this. I'd do that first. Put that in parentheses, square both sides. X squared minus 8 equals, FOIL that. It's going to give me 100 minus 20 root x minus x. And then I have to try and finagle things around to make it work. So x squared plus x, move the 100 over, minus 108 equals negative 20 root x. Put that all in parentheses, that all in parentheses, square both of those to get rid of the radical again. So now you're doing FOIL on steroids right here. And then this one comes out pretty easy as 400x, and then you have some big old huge thing over here. It just gets nasty. So realize sometimes if you graph it on the graphing calculator, you're going to get a better result as long as your window adjusts appropriately for you, okay? All right, what else do we got? Oh, so those are all types of problems you would see on the calculator portion of the test. How would I go about doing this problem? This might be a calculator problem as well. It might not, though. How should I go through it? Add 4. Good. I like that first step. So I'll add 4 to both sides. Then what? Break the problem into 2. Remember, the other part, this will be flipped. That'll be a different answer. So you get there? Try and solve both. What is that? -8. Okay, so just by looking at this, if I were to graph this on a number line, I'd have -4 here, I'd have -8/3 here. It looks like solid dot shading towards each other, so it appears to be an and problem. But what am I going to come across on this problem? Is it an and problem? Is it an or problem? Is it a no solution problem? The graph looks like it's going to be an and problem. But I think it might be no solution. Okay? So let's double check if it is no solution. So let's just take -4 and plug it in. 3 times -4 is -12. -12 plus 10 is -2. The absolute value of -2 is 2. 2 minus 4 is? 2 minus 4 is? -2. Is -2 greater than -6? Meaning, is -2 further to the right than -6 on a number line? Okay, so I think this is going to work for our first problem. Okay, let's check our second one. Take -8/3, plug it in. 3 times -8/3 is going to give me -8. -8 added to 10 is 2. Absolute value of 2 is 2. Is -2 greater than -6? Yeah. Okay, so both are going to work. It appeared for a second it might be no solution, but in this case it's not going to be. So they're shading towards each other. So this is an and problem. How do I take care of the and problem? How do I put it back together? Take the value furthest to the left. Okay, so I'm going to take this and I'm going to flip it. So I'm going to get this. Gotcha? And then this x is the same as this x, so put that back together. And that's your answer. So it didn't turn out to be no solution, where it could have been a no solution if it was equal rather than inequality. But this one worked out nicely. Make sure I'm looking for on the and that you can put it back together. If it's an or, you write the word or. You don't put it back together. Feeling all right? Can I move on?
Yep.
All right. Okay, there's a circle. I want you to graph it. When you graph it, I want to know what the center is. I also want to know what the radius would be equal to. So what's the first thing? I want to know the center of this circle. What's the center? -8, +7. Good. What's my radius? 5. Okay? If I go and graph this, I have -8 and +7. Okay, and I'm going to go 5 out each way. So 1, 2, 3, 4, 5. Oops. And 1, 2, 3, 4, 5 will be over here. 5 up here. So this is basically what the circle is going to look like. I bet you'll have a much prettier one than mine. Okay, so that's the simple version of the circle. Find the center of the circle and the radius. Quick question. If I had that, what would the center of that circle be? 0, 2. Okay, and the radius is 4. So if your squared value is just x squared or y squared, it's not grouped, then your center has a 0 component on it. Okay? What about if I had this problem? I want to graph this circle. I want to find the center and I want to find the radius. What's the very first thing I should probably do to this problem? Okay, I can combine like terms. Right before that, though, I'm going to do something a little different. Do what? Okay, before I do that, though. Divide by 2. Good. So let's get the x squared and the y squareds to be a single version. So I'm going to divide everything by 2. And that's going to give me x squared plus y squared plus 10x plus 2y minus 5 equals 0. Now let's take care of getting the like terms together and moving our constant to the other side. So I'm going to get x squared plus 10x, leave a space, plus y squared plus 2y, leave a space, equals 5. I'm going to complete the square. If I complete the square, my squared term, will I add to the other side? Because I'm going 2 different sides of the equal sign. So if I add to one side, I have to add to the other. Okay? So half of 10. Half of 10. 5 squared. 25. So I'm going to add 25 over here as well. Half of 2. 1 squared. Add 1 over here as well. Okay? So this right here is the same thing as x plus 5, which is the same thing as x plus 5 squared. This right here is the same thing as y plus 1, or y plus 1 quantity squared is equal to 31. What's the center of this circle? Good. -5, -1. What is the radius? 5.5, or I leave it as a radical, which would be? Good. So the radius is going to be the square root of 31, which you said about 5.5. I'm going to leave it up to you. Okay? It's your choice. Feeling okay so far? This is recorded, so make sure if you need to, you watch it over, this evening. Can I move on to the next one? I want you to try this problem. I want you to graph this on your boards. I want you to tell me the domain, the range, obviously the vertex, the axis of symmetry, where it crosses the x-axis, where it crosses the y-axis. Take a couple minutes to see if you can figure that out. All right, quick question for you on this problem. Is this already set up for us to give us a lot of information about the problem?
Yes.
Yes, it is. It's in vertex form. So things that I can answer right away on this problem is I can answer the vertex because it's set up that way. So I know the vertex is 2, 6. That's my first thing. Is that okay? Okay. I can actually graph this with good certainty of how it's going to graph. How fast is it going to grow from the vertex? Right 1, left 1, up how many? Up 3. Okay. Things that we should be able to know. Because I know the vertex, I know the axis of symmetry. The axis of symmetry is just going to be the vertical line, x equals 2. Okay, it's always the x component of the vertex. Do I know with how this problem is set up, where it's going to cross the y-axis? Do I know how this problem is set up, where it crosses the y-axis? Hang on. Excuse me. Thank you very little. All right, so let's graph this problem, what we know so far. Okay, I know that at 2, 6, is my vertex. That's my vertex. I'm going to go right 1 and up 3, left 1 and up 3. So that's what our parabola is going to look like. Does it cross the y-axis? No. Does it cross the it doesn't cross the x-axis? Does it cross the y-axis? What do I have to do in order to find this where it crosses the y-axis? What do I have to do to see where it crosses the y-axis? What math operation? I think you were doing it, Zach. Yeah, I got to FOIL it out. So I'm going to do this. So minus 4x minus 12x plus 12 6. What form is this known as? Standard form. Do I know where this crosses the y-axis now? Where? 0 what? 0.18. 0.18 is where it crosses the y-axis. So it has to be in standard form in order for you to know where it crosses. What would the domain of this be? It's going forever left, forever right. What's the domain? Negative to positive infinity. It's not forever up and down. Where does it start vertically? Where? Where? Where do I start? From riding the elevator up, where am I going to start seeing the graph? At what number? 6. So I'm going to go from 6 to infinity. I just answered that whole question. So, it might be set up in vertex form for you already. If it's set up in vertex form, you can solve an awful lot about it. The only thing you really can't solve about the problem when it's in vertex form is where it crosses the y-axis. And that's where you have to go and FOIL it out first in order to get there, okay? It doesn't cross the x-axis. If it did, you can do a number of things. You can use quadratic formula, complete the square. You can try and factor it if it's factors. All right. What about this one? This is the last one. If I had function at x or y equals this, where's the vertex? Where's the axis of symmetry? X-axis. Y-axis. Domain. Range. What's the only thing I can answer up here right now? Y-intercept, which is what? 0, -4. That's the only thing I can answer up here right now. It's in standard form. Standard form only tells you where it crosses the y-axis. Okay, let's split this up. Okay, how should I go about finding the vertex? Yeah. I like it. Negative b over 2a, what do you think? So if I do negative b over 2a, comma, plug in, that's going to work nicely for me. What's my b value? 18. Good. So I get negative 18. What's 2 times a? 6. So what is my x component of my vertex? Negative 3. What should I do to get my y component of my vertex? Plug it back in where? To the x's. So I'm going to plug negative 3 in right there and right there. So I'm going to get 3 times negative 3 squared plus 18 times negative 3 minus 4. What is negative 3 squared? It's positive 9 and then 27. So this is going to give me 27 minus 54 minus 4. So 27, that's going to give me negative 27 minus 4, which is negative 31. So my vertex is going to be at negative 3, negative 31. Negative 3, comma, oh, whoa, time out. So that's my vertex. Okay? Which is pretty ugly, right? What's my axis of symmetry? X equals what? X equals negative 3. So my axis of symmetry is just going to be that. X is equal to negative 3. Okay? Where across? What's the domain? Do I go forever left and right and have a graph? Yes. So the domain is negative to positive infinity. Where's my range? If I'm riding an elevator up and down, where do I start seeing the graph? And the y direction, up and down. Negative 31. So my range is going to go from negative 31. Graph opens upward, right? So if it opens upward, it's going to go to infinity. So that's my domain and range. Do I know where it crosses the x-axis right now? It's kind of hard to tell where it crosses the x-axis. If you want to find where it crosses the x-axis, you're going to have to use this. That'll tell you exactly. You can complete the square. If this was on the graphing calculator part, graph it, find the zeros. Remember the zeros, when you graph something on the graphing calculator, it's going to do this. Let's say this is what your graph looks like. It's going to ask for the left bound and the right bound. So on that side, it's like that. And if it asks for the right bound over here and the left bound over here, you're above and below the zero. So, guys and girls, make sure your whiteboards are wiped off, stack them neatly over here, put your socks back in the bin, put your markers back in the plastic bin that's next to the pink bin.